So, good evening, ladies. Today I'm going to talk about determinants and what they represent geometrically. And mainly, I want to show you how to find the determinant of a 3 by 3 matrix, which is slightly more different than finding a determinant for a standard 2 by 2 matrix. So, let's start off first. What is a determinant? Well, by definition, a determinant is how an area scales with a linear transformation or any transformation, really. So, let's start with your identity matrix, which is 1, 0, 0, 1, which looks like this. So you've got your I and j vector here, and it's just, right and up as usual. Now let's impose a quite a famous, or I say famous like it's some sort of celebrity, a well-known matrix, which is called the shear, which translates everything to the right. So to understand what this means, this is the coordinates of the I hat vector, and this is the coordinates of the j hat vector. So here, you can see I hat stays the same, j hat gets shifted over to 1, 1 here. So everything gets shifted over. Now, if you imagine this as a shape, you can see that this is a square at first, and afterwards it becomes this fucking parallelogram, trapezium, whatever it's called. I'm terrible at shapes. But the thing is, the area doesn't change. So if we take the determinant, which is given by the formula AC minus BD, you get AC 1 times 1 minus 0 times 0, which is the determinant of 1. So the area is 1. For this one, it would be 1 times 1 minus 1 times 0, which is also 1. So it shows that the area stays the same because the determinant represents how the area changes, it shifts, it transforms. So with that knowledge, I am now going to get on to determinants of big matrices, 3 by 3 matrices, and so on. So, oh shit. There you go. Fucking hell, what's going on? There we go, we still there. Alright, so I will pause the video and I will resume it when I have a 3 by 3 matrix. I forgot to put one up. One sec. Okay, your boy is back. So to find the determinant of a 3 by 3 matrix is a little bit more tricky because you can't use the same formula as we used before. You have to do a little bit more work, which is, everyone hates work. I do as well. So to do this, you have to know about something called a minor, which is, say, if I pick the number 7 here, the first part of the matrix, and I eliminate the row and the column that it's on, I get 4 numbers here, this 2 by 2 matrix. So, for example, for 7, the 2 by 2 matrix will be 3 minus 1, 4 minus 2. And computing the determinant of that, you get 3 times minus 2 minus 1 times 4, which is equal to minus 6 plus 4, so minus 2, right? Now if I do it for 2 here, get rid of that line, get rid of that line, I'm left with, let me just write 7 above there so we know it's for the 7, this one's for the 2. I get where 0, minus 1, minus 3 and minus 2 because I'm eliminating that, and then I get these 4 numbers. So to compute the determinant of that, it's 0 times minus 2 minus 1 minus 3, which is equal to 4. Minus 1 times minus 3. Sorry, 4. Where did I even get 4 from? Minus 1 times 3 is 3, so it's minus 3. And then to compute it for the last one, which is 1, get rid of all of that, and we just do what we did before. That's a terribly drawn one. Do what we did before. So 0, 3, minus 3, 4. Are you guys still with me? I know I'm a little bit boring today, but I do really want to show you this. So 0, 4 minus 3 minus 3, which is, there you go, which is 3 times minus 3, which is not minus 9, which is positive 9 because you've got a minus there. So these are the 3 numbers here. And now I have to show you something else that is not very well explainable, and I'm really not sure what the purpose of it is, but it's something you have to know. And I've tried searching everywhere for it, but I can't really find anything about it. So it's this sine thing where you've got these alternating signs in the matrix, and you need to times the determinant of all of these by that. So for 7, minus 2 times positive is still minus 2, so we have minus 2. Minus 3 times negative is 3, and 9 times positive is 9. So now we have these three numbers here. We have to multiply them by their original values here. So we've got 7 times minus 2 plus, because now we're adding everything together, 3 times 2 plus 9 times 1. So that's minus 14 plus 6 plus 9, which is 1. So the determinant of this big ass matrix is 1, and that's how you do it. You can repeat the same thing for any line here, so the 0, 3, minus 1, or the minus 3, 4, minus 2, and it'll all return 1 as well. So that's the determinant of this matrix. It doesn't shift the area of anything, it just translates it. So yeah, bit of a boring video, but it has to be done.